Welcome to this lecture. This lecture is basically based upon the four-vector formulation of electrodynamics. And here I will try to express Maxwell's equation in terms of four vectors. And I will show also that the wave equation obtained from Maxwell's equations for free space is found to be invariant under Lorentz transformation. So for this, let us consider Maxwell's equations. So as we know from earlier lectures that using Maxwell's equations, for free space, we have to write the following wave equation. For electric and magnetic fields. The equations are like this: del square E plus 1 by C square curly square E over curly T square equal to 0. Sorry, not plus, but it is equal to, right? And another equation for the magnetic field is equal to del square H equal to 1 by C square curly square H over curly T square. So let me call it as equation 1. In general form, these equations can be written collectively as these two equations, means del square psi is equal to 1 by C square curly square psi over curly T square, which must be equal to 1 by C square curly square psi over curly T square minus del square psi, it is equal to 0. Or I can write it as 1 by C square curly square over curly T square minus del square psi is equal to 0, and let me call it as equation number 2. Before proceeding further, let us recapitulate few things. As we know that x naught is equal to minus x naught, x naught, this is a contravariant, this is covariant, this is a contravariant, and x1 is equal to minus x1, x2 is equal to minus x2, and x3 is equal to minus x3. This equation I have taken from four vector components in covariant and contravariant form. This is basically equation number 5 in lecture R5. The relationship between covariant and contravariant vectors. Between covariant and contravariant vectors. Also, we know that x mu must be equal to c square t square minus x square minus y square minus z square, or I can express it as x naught plus x1 plus x2 plus x3. This is also from the earlier lecture. Equation number 6 and 7. Now let us consider the gradient. In 3 dimensions. So if I consider the gradient, then the gradient can be written as del must be equal to curly over curly x, curly over curly y, curly over curly z, or it may also be written as ex curly over curly x, ey curly over curly y plus ez curly over curly z. So in the similar fashion, I can write down gradient for 4 vector form. So 4 vector form of gradient can be written in the similar fashion as this curly over curly x mu must be equal to curly over curly x naught, curly over curly x1, curly over curly 2, and curly over curly z. Sorry, it's not like this. Curly over curly x2, curly over curly x3, or where x naught is ct. In some books people have taken iota ct, x naught is equal to ct, but in some text people are also taking it as iota ct. Both are equally good. So here I am taking that x naught is equal to ct. So using this will become 1 by c curly over curly t, comma curly over curly x, curly over curly y, curly over curly z. This in compact form, this can also be denoted as curly mu is equal to curly over curly x mu, or it is equal to 1 by c curly over curly t and del, or curly t by c comma curly x curly y curly z. So this can be written in this either form. So let me call it as equation number 5. Also we know that x mu is equal to g mu nu x mu, and x mu is equal to, these are the relationship between covariant and contravariant vectors. So using this we can express that curly mu is equal to g mu nu curly nu, which implies curly naught curly 1 curly 1 curly 2 curly 3, it must be equal to 1 0 0 0 0 minus 1 0 0 0 0 minus 1 0 0 0 0 minus 1, and it is curly not, curly 1, curly 2, curly 3, and it can also be written as if we multiply these to this with this, so I am getting curly not minus curly 1 minus curly 2 minus curly 3, and this leads to a conclusion that this curly not must be equal to curly not, and curly 1 is equal to minus curly 1, and this curly 2 is equal to minus curly 2, and curly 3 equal to minus curly 3, which implies that curly over curly x naught is equal to curly over curly x naught. Curly over curly x1 is equal to curly over curly x1 with negative sign, and curly over curly x2 is equal to minus curly over curly x2, which implies curly over curly x3 is equal to minus curly over curly x3. Or this may leads to the fact that curly mu is equal to curly over curly x naught, curly over curly x1, curly over curly x2, curly over curly x3. Or this may also be written as curly over curly x naught, comma minus curly over curly x1, comma minus curly over curly x2, comma minus curly over curly x3, and this may be written as curly over curly t, comma curly over curly x, curly over curly y, minus with my negative sign of curly z. Or you may write it as one by c curly over curly t, comma minus L, and let me call it as equation number 6. So now curly mu, it can be written as G mu curly mu and curly mu, or it can also be written as curly over curly x mu and curly over curly x mu, right? And this is equal to 1 by c curly over curly t, comma minus del, and 1 by c curly over curly t, del operator, and this product will be equivalent to 1 by c square curly square over curly t square minus del square, and this further will become 1 by c square curly square over curly t square, comma curly square over curly x square, comma curly square over curly y square, comma minus curly square over curly z square. Or this can be written as 1 by curly square over curly x naught square, comma curly square over curly x1 square, comma curly square over curly x2 square, comma minus curly square over curly x3 square. So all will represent the same thing, and let us denote it by another symbol. D'Alembert square, D'Alembert. So this is basically this Quabla square. This is known as Quabla. So this Quabla square is equal to, is known as D'Alembertian operator or wave operator, right? So this is a new thing which we have defined. So therefore, this is equal to 1 by c square, curly square over curly t square, comma curly square over curly x square, comma curly square over curly y square with negative sign, and curly square over curly z square, or we may call it as 1 by c square curly square over curly t square, comma minus del square, or simply we can write down it as del square is equal to 1 by c square over curly t square minus del square, operating both sides by psi. But this is equal to 0. This is here we have used the equation number 2, right? It's basically the wave equation. Now we have to see that this wave equation is invariant under Lorentz transformation. Now the wave equation is invariant under Lorentz transformation. That is, you have to see that Kaplan square is equal to Kaplan prime square, or you have to show this thing. So for this we have to check whether this is invariant or not. That's what we have to check. So to prove it, let us proceed as follows. So consider 1 by c square curly square over curly t square minus curly square over curly x square minus curly square over curly y square minus curly square over curly z square. Also consider the Lorentz transformation. If I consider Lorentz transformation, then this t prime must be written as gamma t minus b by c square into x and this x prime is equal to gamma x minus bt, and this y prime is equal to y prime and z prime is equal to z, and its derivative with respect to t can be written as gamma, also gamma t prime with respect to x comes out to be minus gamma b over c square, or I may call it as minus gamma beta over c, because beta is equal to v over c. Similarly, I can find out the derivative of x prime with respect to t. It comes out to be minus gamma b. Also, I can write down its derivative with respect to x, and it comes out to be gamma. It is equation number 10. And this may leads to curly over curly y prime is equal to curly over curly y, or curly over curly y. If I take its again differential, this may leads to curly z prime square, curly y prime square, and similarly curly over curly z prime is equal to curly square over curly z prime, and curly square over curly z prime square must be equal to curly square over curly z square. So this is equation number 11, and this is equation number 12, right? Now I will make use of these two equations in later on. All the quantities are needed to be substituted later on. So keeping these in mind, so let me consider t. It is basically a function of x prime and t prime and vice versa. So if I take its curly over curly t, then it can be written as curly x prime over curly t and curly over curly x prime plus curly t prime over curly t into curly over curly t prime, and using equation 9 and 10, its value will be minus v gamma, and its value will be gamma. So that means this will become minus v gamma curly over curly x prime plus gamma curly over curly t prime. Now I can find out in the similar way curly square over curly t square, and it can be written as curly over curly t and curly over curly t. So it is curly over curly t, and its value can be substituted from here. So it is v gamma curly over curly x prime plus gamma curly over curly t prime. So if I open it, then it can be written as minus gamma b curly square, curly over curly t and curly over curly x prime plus gamma curly over curly t and curly over curly t prime. Now I can substitute these values from here again. These two values can be substituted here. So it is basically minus gamma v minus v gamma curly over curly x prime plus gamma curly over curly t prime curly over curly x prime plus gamma minus v gamma curly over curly x prime plus gamma curly over curly t prime curly over curly t prime. So this, after simplification, will become, if I open these brackets, then it can be written as gamma square v square curly square over curly x prime square minus gamma square v curly square over curly x curly t prime and curly x prime minus gamma square v curly square over curly x prime curly t prime plus gamma square curly square over curly t prime square, and this is basically curly square over curly t square. It can be written as gamma square. This can be written here, so it is curly square over curly t prime square minus 2. These two can be put together because both are identical terms, so 2 gamma square v curly square over curly x prime curly t prime plus gamma square v square curly square over curly x prime square. So this is one equation. Now similarly, I can find out the expression for curly square over curly x square. So let us consider that x is a function of x prime and t prime. So now curly over curly x can be written as or I can say that x prime is equal to x into x and t, one and same thing. Both are independent, so it is curly x prime over curly x and curly over curly x prime plus curly t prime over curly x and curly over curly t prime. So using equation 9 and 10, this is gamma and its value will be minus gamma beta over c. Here I have used equation 9 and 10, right? So this is basically gamma curly over curly x prime minus gamma beta over c curly over curly t prime. So therefore curly square over curly x square, it can be written as curly over curly x curly over curly x. It is curly over curly x and the value will be gamma curly over curly x prime minus gamma beta over c curly over curly t prime. I have substituted their values. So if I open it up, and it will become it is basically gamma curly over curly x and curly over x prime minus gamma beta over c curly over curly x and curly over curly t prime. And now I will substitute these values from here again. So if I substitute these values, what will happen? This is equal to gamma curly over curly x prime minus gamma beta over c curly over curly t minus gamma beta over c gamma curly over curly x prime minus curly beta over c curly over curly t prime. It is curly over curly t prime. So this after simplification will become, so if I simplify it, then it is gamma square curly square over curly x prime square minus gamma square beta over c curly square over curly t prime, sorry it's prime, curly t prime. Okay, so this term is also sitting with it, so yeah, so it is curly square over curly t prime and curly x prime minus gamma square beta over c curly square over curly x prime curly t prime plus gamma square beta square over c square. It is curly square over curly t prime square, and these two terms can be put together. So that means this curly over curly x square, it can be written as gamma square curly square over curly x prime square minus 2 gamma square beta over c curly square curly x prime curly t prime plus gamma square beta square over c square, so curly square over curly t prime square. This is equation number 40. So using equation 13 and 14, we can rewrite wave equation in terms of primed coordinates. So that means equation 13 and 14, 1 by c square curly square over curly t square minus del square, it can be written as curly square curly 1 over c square curly square over curly t square minus curly square over curly x square minus curly square over curly y square minus curly square over curly z square, right? And substituting these values, so it is 1 by c square gamma square curly square over curly t prime square minus 2 gamma square v curly square curly x prime curly t prime plus gamma square v square curly square over curly x prime square. This is the value of this, and plus or minus gamma square beta square over c square curly square over curly t prime square minus 2 gamma square beta over c curly square curly x prime curly t prime plus gamma square curly square over curly x prime square. This is the value of this one, and their values are simply minus curly square over curly y prime square minus curly square over curly z prime square, right? They are written as it is, but what I will do, curly square over curly x prime square, I have written it as additional term, and I written, so it's same term with the negative sign can also be written, because this will cancel out, right? So this is one and same thing. I expressed it in this form because this is equal to del prime square, right? So that means what I can do, I can write down it as it is. First of all, I will consider the term curly square over curly t square, both the terms together, right? So if I club these two terms, then it is basically it is 1 by c square gamma square from here, and from here it is minus gamma square beta over c square. It is beta or beta square. Let me recall. Okay, it is basically not beta, but it is beta square c square. Yeah, so if it is beta square c square, and here the outside will be curly square over curly t prime square, plus again I have taken these terms together, this term and this term, right? So it is minus 2 gamma square v over c square, from because this c square gets multiplied here, and it is minus plus 2 gamma square beta over c, and this b over c square can be written as beta over c, and here it is curly square curly x prime curly t prime, and these two terms can put together. These two terms put together, sorry, not these two, but this is also along with it. So it is plus gamma square b square over c square, because the c square gets multiplied here, plus, and here this minus is multiplied with, so minus gamma square plus 1, and it is curly square over curly x prime square. Let me try to go to these terms. So this term is equal to gamma square over c square. This is gamma square over c square, and this is 1 minus beta square. Also, I know that this is gamma square is equal to 1 over 1 minus beta square. So that means gamma square 1 minus beta square is equal to 1. So this quantity is 1. So it means this is 1 over c square. Now let us come to this term. It is gamma square. Okay. So it is minus 2 gamma square beta over c plus 2 gamma square beta over c, these two terms, and this is 0. And let us come to this term. So it is gamma square can be taken out, so it is it's beta square, right? So it is beta square minus 1 plus 1, and this is gamma square 1 minus beta square, and minus will be here plus 1, and this whole of the quantity is 1, so minus 1 plus 1, so that means this term will also be 0. Oh, sorry. And another thing which is there is minus del prime square. It was also sitting with it, right? So that means this equation will become now 1 upon c square curly square over curly t square minus del square, it must be equal to 1 by c square curly square over curly t prime square minus del prime square. So that means from here what I am concluding, that quadra square must be equal to quadra prime square. So that means this is an invariant operator, and this leads to the invariance of wave equation. right? So this is all about the 4-vector formulation. Right, so we can say that Maxwell equation is invariant for free space. And thanks for watching this video.